Right guys, hi, very good evening everyone. Welcome to the session. Welcome once again to Ohm Institute and welcome to the series once again, that is the Learn Concepts through PYQs. Yes, we all know PYQs are very important. Okay, and what we are doing in this particular series, as I briefed you, that we will take up important PYQs of specific topics. Like in the earlier session I took rank of matrix, and today I am going to take linear system of equations, right? And from this topic we'll take up PYQs and we'll have a reverse teaching methodology. Yes, with respect to every PYQ we are going to of course learn some particular concept, okay, and this way we'll cover up the linear system of equation, first starting with the non-homogeneous system of equation, because linear system of equation itself is categorized into non-homogeneous system of equation as well as the homogeneous system of equation. So of course we'll first start with the non-homogeneous system of equation and then eventually move towards the homogeneous, because the theme of questions, actually the background concept is pretty much similar, but the theme of questions, okay, from homogeneous system of equation is slightly different and more of conceptual nature. Okay, yeah, so let's get started. Very good evening everyone. Good evening Ramji, good evening Mr. Unlucky. Yes, come on, update all your friends that the session is now live and they can start joining the session. Okay, quickly share the session to all your friends. Right guys? Yes, so yeah, let's get started. Let's get moving ahead. Okay. So first question of the day, as I'm telling you, we'll take up questions, and with questions we'll keep learning the concept. So this is what here, the first question for the day in front of you. Okay. Here it is. The following system of equations will have what? The following system of equations, starting with the GATE 2011 2 marks question. The following system of equations will have not. Now see, before I teach you the complete concept, the concept here in solving the linear system of equation is all about handling the Rouche-Capelli theorem, which eventually talks about the rank of the matrices. Okay, which matrices I'll talk about. Okay, but what is the concept of rank that we have seen yesterday in the previous session? I mean, which I took it on Tuesday, okay, sorry, on Thursday. And then, you know, the same concept of rank where the Echelon form conversion and all was discussed probably can be used up here, right? Okay. Yes, good evening all, good evening everybody, keep joining the session. All right. Yeah. So starting up with this question. Now see, before we solve it by the official theorem, I will just show you an observation. Okay. So as to understand what is the theme of the question. See dear, what is the observation? There are three equations. Okay. I can call the three equations at what? 1, 2 and 3. Suppose just name the equations as 1, 2 and 3. Okay. Now if you have named this as 1, 2 and 3, now keep looking. Okay. What I'm going to do, okay, simply just I'm going to add the equation 1 and 2. Whether or not the system will have a solution or not, I'll explain you that by the logic. Okay, and that's also like a simple shortcut, and then eventually I will come towards, you know, solving this question. So dear, if you are going to add up the equation number 1 and 2, what you are going to get? If you add up the equation number 1 and 2, okay, so x plus 2x will give you 3x, okay, with respect to y. Okay, just a second. Okay, so x plus 2x will give you 3x. With respect to y, if you see, 2y plus y will be equal to 3y. And with respect to z, if you see, z plus 2z again is 3z. And on the right side, 6 plus 6 is equal to 12, correct? Okay, so this is what is the calculation. Okay, 3x plus 3y plus 3z is equal to the 12. Now, if 3x plus 3y plus 3z equal to 12, dear, what is going to be x plus y plus z? Okay, if you divide by 3, if you here are going to divide by 3, the result is x plus y plus z is equal to 4. The result is x plus y plus z equal to 4 if you divide by 3. Now, adding 1 and 2, I am getting the result that x plus y plus z is equal to the 4. Correct, na? X plus y plus z is equal to 4. But what does equation number 3 says? If you bring the equation number 3 into the picture again here, dear, keep looking, okay. So equation number 3 says that x plus y plus z is equal to 5. Now there are three numbers. What is the meaning of solving this system of equation? Finding the three variables x, y, z, so that when you find the values of x, y, z, the three equations should be satisfied. All the three equations should be satisfied simultaneously. All of them should be satisfied. Correct, everybody? Okay, so now can you find out any value of x, y, z so that their sum is 4 also, so that their sum is 5 also? Okay, is it possible so that their sum is 4 also, at the same time their sum is equal to 5 also? Is it possible? It's not going to be possible. So these equations are actually contradicting here. Okay, this is what is said to be the case of contradiction. What is happening here? The equations are just contradicting in nature. The equations are just contradicting in nature. Okay, I call it as contradiction. Okay, contradiction means when the two equations, okay, they do not agree to each other. When the two equations, they do not agree to each other. And if they do not agree, you cannot find out any value of x, y, z. Okay, the system of equation is unsolvable. You cannot find out any value of x, y, z so as to get a solution. So whenever the equations don't agree, okay, we call it as contradiction. Okay, one set of information is different. One set of information says that x plus y plus z is 5, and one set of information says that x plus y plus z is equal to 4. Okay, they do not match to each other, and hence when there is the contradiction, this is what is the case of no solution. The system of equation is unsolvable. You are not going to get any particular solution from here. Is this clear, everybody? Okay, is this clear? In case of any doubt, you can anyways let me know, right? You can let me know in case of any particular doubt, okay? Okay, yeah. Right, now what is the Rouche's theorem? That I have not introduced, that we will come to it slowly, don't worry. Okay, this is what is simply, okay, the contradiction, and this system is unsolvable. Okay, so contradiction leads to the system being not solvable. Okay, is this philosophy clear? Before I tell you, before I teach you the theorem, okay, let's look into the another question. Okay, what is there in the another question? Okay, have a look into it and then let's decide. Okay, this is anyway solved. Okay, so what is the next question? Have a look into this one. Just a second. Yeah, here it is. Probably the next question on your screen. Here it is. Gate 11 again, 2 marks question. Gate 11 EC, 2 marks question. Okay, on the logic I told you, can you say, now this question is directly talking about no solution. The system of equation has no solution. Okay, for what values of lambda and mu? For what values of lambda and mu? Okay, even if you try to observe the options, the value of lambda and mu are around 6 and 20. The values of lambda and mu are around 6 and 20. Okay, so the system of equation has no solution for what values of lambda and mu? Can we figure out now? Can we figure out? The system of equation has no solution for what values of lambda and mu? Okay. So yeah, let's try to figure out. So when I'm telling you it's about no solution, what is the concept I told you? No solution is related to contradiction. Okay, is related to what? Is related to contradiction. It is related to contradiction. Okay, now contradiction means equations not agreeing to each other. Okay, different informations, different types of information by the same x, y, z. Okay, so now let's see. Options, if I just note, now lambda is around 6 or not equal to 6. Okay, now look into the equation again. I'll just name these equations. Now what is there? I can name the equations as what? Okay, let me name it as 1, let me name this as 2, let me name this as 3. These are the 3 equations. Okay, x plus 4y, this much of the part is common in equation number 2 and 3. Equation number 2 says that x plus 4y plus 6z. Okay, and that is why lambda equal to 6 or not equal to 6 comes into the option. So dear, if I put lambda equal to 6, okay, what about third equation then? If I put lambda equal to 6, what is going to be the nature of third equation? I'll write it here. If I am putting lambda equal to 6, what will third equation say? Keep looking. Third equation will say that, third equation is going to say that x plus 4y plus lambda is put, I'm putting lambda equal to 6, so plus 6z is equal to mu. Plus 6z is equal to mu, correct? Whereas equation number 2 says that, writing the equation number 2 beneath it, okay, parallelly let us write down both. So equation number 2 says that x plus 4y plus 6z is equal to 20. Okay, you want node con solution, and that comes with the case of contradiction. So what will I say now? Left hand side is matching. Okay, there are 3 variables x, y, z, so that x plus 4y plus 6z is equal to 20. But equation 3 says that x plus 4y plus 6z is equal to mu. So dear, here is the place where you can make contradiction. How? If mu not equal to 20. right? If mu not equal to 20, right side do not match. That means one of them say that x plus 4y plus 6z is 20. Another one says that x plus 4y plus 6z should not be 20. What is this? They are fighting. Contradiction. Okay, so mu not equal to 20 will definitely bring about what? Will bring about the contradiction in the system of equation, and then only we say that the system of equation is having no solution, non-solvable. Then only we say that the system of equation is having no solution. So correct answer for no solution should be lambda 6 mu not equal to 20. Okay, what is the option? I'll tick mark B. Lambda equal to 6 mu not equal to 20. Correct everybody? Yes, Ramji and Surya, correct answer. It is B. Okay, it looks B, correct na? It looks B. Lambda equal to 6 and mu not equal to 20 is the correct answer. Lambda equal to 6 and mu not equal to 20 is the correct answer here. Okay, is the correct answer here. Okay. Okay, fine. Okay, see, without teaching any theorem till now, I have given you the answer here. Simple, understanding. Okay, logical answer. This is what is simply known as the logical way of solving the question. Okay, logical approach, logical way of solving the question. Okay, now what is next? Okay, what is next? Okay, now let's slowly dive into the method as well. Okay, let's slowly dive into the method as well. Okay, so what is the method? So that you know every type of question you can handle. Some questions are logically solved. For some question, we need the complete concept and the background. Okay, so now let's move ahead and have a look into. I'll come back to the same question, okay, with the help of Rouche-Capelli's theorem. What is that Rouche-Capelli's theorem? Okay, so again taking three variable system as a generalization, because I tell you that 99% of the questions that you are going to expect from this topic are around three variables. Let me make it very clear. 99% of the questions are going to be around three variable. Okay, so let's consider a system of three variables, something like this given to you as a11x plus a12y plus a13z equal to b1. Okay, then you have a21x plus a22y plus a23z equal to b2. Okay, the next one. Okay, and the third one, a31x plus a32y plus a33z equal to b3 equal to some number b3. Correct? Okay, we first convert them into the matrix form, arranging all the coefficients. Okay, like a11, a12, a13, the coefficient of first equation into the first row. Okay, multiplying by the column vector. Okay, x, y, z. This is the column vector, which is the column vector containing the unknowns. We call it as the unknown vector x. Okay, so that when you multiply the first row and first column, this is how matrix multiplication will happen. Na? You will get the first equation a11x plus a12y plus a13z equal to what? Equal to the first element on the right, which is b1. Okay, so similarly, the second equation coefficient 2, 1, 2, 2, 2, 3 are put in the second row. Then 3, 1, 3, 2, 3, 3. The third row, the third equation coefficients are put in the third row. We define it as the linear system of equations as the ax equal to b. Okay, so not deriving it, of course, the intent of today's and all of these sessions are practicing PYQs, but learning concept through PYQ. Even if you don't know the topic, you can cover up the topic through my classes. Okay. Linear system of equations, you will be able to solve any type of question. Only thing is we don't spend a lot of time in the derivation. Okay, we'll just talk about the theorem and start solving the question. Rather, we are first taking the question and then I'm introducing the concept. Two questions I have solved without any theorem. We have solved by logic. Okay, I'll go back to that question also. Okay, so you know the matrix A, which contains the coefficients of x, y, z. Okay, this particular matrix A, which simply contains the coefficient of x, y, z, will be known as the coefficient matrix. Okay. This is what is simply going to be named as coefficient matrix. Okay, and then the A is to be augmented matrix. You know, augmented matrix is a generalized name used to, you know, represent the situation when two or more matrices are combined together, are put inside a single matrix. So what I have done, I have taken the A matrix, inside that only I have put the column of B. Okay, that becomes A is to B. Okay, the larger matrix. Okay, the A is to B, that is the larger matrix, correct now? Okay, now what is that Rouche's theorem? Rouche-Capelli theorem, or simply also known as Rouche's theorem, states that a system is consistent. What do you mean by system being consistent? When I say system being consistent, I mean the system is solvable. Okay, it will give you some solution. Now there are multiple cases. If it is solvable, sometimes it can give you only one solution, or sometimes it can give you more than one solution. Sometimes it will give you more than one solution. The how many solution it is going to give, either one solution or more than one solution. Okay, that also we'll figure out. But a system is solvable, it will give you something. It is consistent if and only if the rank of coefficient matrix should be equal to the rank of augmented matrix. That's what I just told. Coefficient matrix means A. Augmented matrix means A is to B. The rank of both of them must be equal. Okay, the rank of both of them must be equal. The rank of both of them must be equal. All right. Okay, so let us further split this. Okay, Rouche-Capelli theorem as a flow chart, Ax equal to B. Okay, So one thing is there, I told you, if rank of A not equal to, if I go reverse, if rank of A not equal to rank of A's to be system is inconsistent, unsolvable. Okay, and that is what no solution is. So if both the ranks are not equal, the system of equation clearly will have no solution. That is the conclusion. Hope that is clear. Okay, but if both the ranks are equal, okay, then the system is solvable. Okay, suppose both the ranks are equal and equal to R, okay, if R is equal to N, both are equal and equal to R if R is equal to N. Now what is N? N here means the number of variables, like 3 variables. Our question of concern was 3 variables. So if both the ranks are equal and equal to N, like equal to 3, the system will have unique solution. If both the ranks are equal but less than N, the system will have infinite solution. Okay, now let us learn this with the previous question, and then this particular condition, unique solution, I will separate out this and have a slide discussion onto this separately. Okay, having a little bit more importance here. Unique solution can be many times solved directly. Okay, but yeah, let us go to the previous question. In previous question we got the answer no solution. That was a logical approach. Now let us understand this. Okay, let us understand this particular theorem. Have a look into it. Okay, so this is what it is. I'll put down this one. I'll put down this one as my method number 1. No solution was the question, so I made a contradiction where no solution is guaranteed. Now have a look into the next. Okay, what can be the next method here? Okay, what can be the next method here? Okay, let's understand the next method here. Okay, let us try to understand the next method here. Okay. So yeah, I'll write down the equations basically. It didn't turn up. Okay, so what are the equations given to me? Okay, keep looking. What are the equations given to me? Where is that question gone? Just a second. Yeah, x plus y plus z equal to 6. That is the first equation. Okay. X plus y plus z equal to 6. That is the first equation. Next is x plus 4y plus 6z is equal to 20. And the last is x plus 4y plus lambda z. Okay, we have not found anything about lambda and mu. Fresh method. Plus lambda z equal to mu. Okay, what is the A is to B matrix? The important thing is, can we directly convert this into the matrix? Okay, so let me, rather than this writing down the equation, now let me convert them into the number. Okay, so you know the coefficients here will be 1 1 1. Okay, let me write down here. Okay, let me write down for you. So see here, what is the A is to B? Okay, then we have to talk about rank. Okay, so what is that A is to B? First 1 1 1, then is 2. Okay, 6. Then second row. Okay, second equation will come here, 1 4 6. Only the numbers of the second equation will come up here, is to 20. And then third row. Okay, 1 4 lambda is to mu. Okay, these are the numbers of the third one. Correct? These are the numbers of the third one. Okay, so now what we will do is, okay, let's talk about rank. Let me just copy it and bring into the next one. Let's take this here and start solving it again. Okay, this is the A is to B matrix. Okay, now to talk about rank, it is important to convert into the echelon form. Okay, because there are multiple methods we discussed about rank, the echelon form, the determinant method, okay, which is typically for square matrices, or the dependency independency. Okay, I will again bring up that dependency and independency technique here. But first, let us go to the official method of rank. What is the official method of rank? Echelon form. What is the official method of rank known as the echelon form? Okay, so understand. Okay, in echelon form, we want to, count the number of starting zeros. Okay, so let m be the number of starting zeros. Okay, keep counting here. Okay, let's say m is the number of starting zero. No starting zero here, no starting zero here, no starting zero here. But I want the starting zero in the increasing order. M is again the same parameter I defined in the last class, number of starting zero. Okay, so let me at least make this as 0, and at least let me make this as 0. I want to make the number of zeros in the next row in the increasing form. Okay, so I will make at least these two 0, and for that what will come? Okay, elementary row operation will come. Okay, so we cannot operate on a single element, but we can operate on a complete row. Okay, R2 minus R1, 1 minus above 1. I want 0 here. Similarly, 1 minus this one, R3 minus R1. So R2 minus R1 and also R3 minus R1. The next operation will be R3 to be replaced by R3 minus R1. R3 to be replaced by R3 minus R1. Correct? After doing this, what is the result we are going to get? Let us see. After doing this much, what is the result we are going to obtain here? Okay, so that is 1, 1, 1 is to 6. I have not changed R1. We are only changing R2. R2 is R2 minus R1. So do R2 minus R1, dear. Okay, how do you get? How much do you get? 1 minus 1. Okay, 4 minus 1 is 3. 6 minus 1 is 5. Okay, 20 minus 6, 14. Then R3 minus R1, again 1 minus 1, 0. Again 4 minus 1 is 3. Now this is lambda minus 1 and this is mu minus 6. This is mu minus 6. Correct now? Okay. Now, what is the number of starting zeros? Okay, if I again write down the value of these m's, okay, what is m here is 0. But now here I have got 1 0, here I have got 1 0. Okay, still I have got 1 1 0. I will improve one more. Okay, this is again 1 0 and this is again 1 0. Okay, this is again 1 0. Okay, so is it again following an increasing order? Does it still follow an increasing order? No, this is still the same. Like here, it was same. Here, the second and third row same. That means to make it in the increasing order, echelon form. Refer to the previous video if you have not attended it. Okay, I want to make this also 0 because if I make this 0, then the third row will have 2 0 and I'll get the increasing pattern. Okay, I'll get the increasing pattern. And how you can do it? Simply 3 minus the above 3. R3 minus R2, because the operation of course will be applied to the complete row, not to a single element. Okay, so if I go to the next, I'll just write down the operation here. What is that now I am applying? R3 will now be written as R3 minus R2. R3 minus R2. Okay, let me do this much. Okay, if I do this much, what is the A is to B matrix? Okay, A is to B matrix. So 1, 1, 1, 6. Okay, because the first row was not disturbed, correct? 1, 1, 1, 6. Then second, okay, 0, 3, 5, 14. That is also, and I'm going to change only R3. So 0, 3, 5, 14. What is there in the next? Yeah, 0, 3, 5, 14. And what is there in the next? Okay, then R3 minus R1. Okay, 0 minus 0 is 0. 3 minus 3 is 0. Okay, then the next element you see. What is there in the next element? Lambda minus 1 minus 5. Okay, so that is lambda minus 6. And the last element. What is there in the last element? Mu minus 6 minus 14. Mu minus 6 minus 14 is how much? Mu minus 20. This is how much? Mu minus 20. Clear? This is what is the answer. Okay, now if you again see the number of starting zeros, yes, if you see the starting zeros, here it is nil, here it is 1 starting 0 and then you have 2 starting zeros. Okay, number of starting zeros are in the increasing order. Okay, number of starting zeros now follow the increasing order and the matrix is now in the row echelon form. And the matrix is now in the row echelon form. Clear? The matrix is now in the row echelon form. The matrix is now in the row echelon form. Correct? The matrix is now in the row echelon form. What to do next? Okay, what to do? Now let's start drawing out the results. Okay. If you want the rank of A, unique solution, no solution, infinite solution. The question was actually about no solution. We have solved it by the logic, but now let's take up all the three with respect to this example. If you want no solution, what are you looking for? See, if you want no solution, okay, if you want no solution, so see, start like this. If I, play with lambda, if I start playing with lambda, dear, if lambda alone is equal to 6, what will happen? If lambda alone is equal to 6, okay, the last row of A will be 0. Correct, na? The last row of A will be 0. right? You see here, the last row of A will be 0, and if the last row of A is equal to 0, okay, A will have only 2 non-zero rows and rank of A will be 2. Rank of A will be 2, clear? Rank of A will be 2. So this is very clear that if I take lambda equal to 6, rank of A, okay, because what we learned, row echelon form, dear, recall what we learned in the row echelon form, that the rank of the matrix, if a matrix is in row echelon form, rank of matrix is known as the number of non-zero rows. Is known as the number of non-zero rows. So how many non-zero rows? 2. Okay, because this row will become 0, na? This row will become 0. Rank of A will be 2. Correct? Rank of A will be 2. At the same time, now there are two conditions. Okay, if mu also becomes 20, if mu also becomes 20, then what is going to happen? If mu also becomes 20, then lambda minus 6 is anyway 0, mu minus 20 will also be 0. The entire row of A is to B. See, because there are two parts, one is the A is to B matrix and one is this much, which is the A matrix. Rank of A I decided 2. Okay, but if mu minus 20, if mu is also 20, then this entire row is 0. So if you look into the bigger matrix, what is my bigger matrix? A is to B. So for the bigger matrix, what is going to be the rank? For the bigger matrix also, the rank will become 2, only 2 non-zero rows, the above 2. Okay, only 2 non-zero rows. Okay, so what is the rank? What is the rank now? For A is to B is 2. What is the rank for A is to B is equal to 2. What is the rank for A is to B is equal to 2, correct? Rank of A also 2, rank of A is to B also equal to 2. Okay. And when rank of A equal to rank of A is to B, okay, then the system of equation, and both of them are equal but less than 3, the system of equation will have infinite solution. The system of equation will have infinite solution, because what is happening here is, see, what has happened here under this condition. Okay, just keep looking here. I'll write down, I'll just move aside and write down the condition here. Okay, see, so what has happened here? Rank of A is equal to rank of A is to B, but both of them are less than n. N is the number of variables here. Okay, so this is what is the condition known as the condition of infinite solution. This is what is the condition of infinite solution. Okay, but now the interesting part is, if mu not equal to 20, if mu is not equal to 20, then what is happening? Okay, lambda minus 6 is 0. Okay, but mu is not equal to 20. So here you get non-zero number. So the row of A is 0, but the row of A is to B is non-zero. Row of A is to B is non-zero. So what is the condition here? Okay, if mu is not equal to 20, then you can say that rank of A is to B will be equal to number of non-zero rows of A is to B, which is equal to 3. Which is equal to 3. Okay, and hence I can say that now the rank of A, okay, is not equal to rank of A is to B, and that is what is the condition of no solution. That is what is the condition of no solution. Correct, everybody? That is what is the condition of no solution. Okay, so see, that is what actually we solved also. The same thing we have solved also earlier. What have we solved earlier? If you go and look into the solution, the answer is already in front of us. We have solved this question logically. Lambda equal to 6, mu not equal to 20. Lambda equal to 6, mu not equal to 20. Hence our question was solved. Hence our question was solved. Lambda equal to 6, mu not equal to 20. Finish. Okay, finished. Okay, by the official method also we have come up with the same answer. See, okay, no solution is obtained when lambda equal to 6 but mu not equal to 20. Okay, lambda equal to 6 divided into two subcases. Okay, I have taken lambda equal to 6. Now first condition mu equal to 20, second condition mu not equal to 20. mu not equal to 20, right? Okay, but if lambda itself is not equal to 6, then what will happen? Now, next condition is if lambda itself is not equal to 6. If I add a condition, let me try to add it here only in this much of the space. Keep understanding in the flow. Okay, the next condition itself is lambda not equal to 6. What does this mean? Very important point, very, very important point. If lambda not equal to 6, you see here, this term is non-zero now. If this term is non-zero, okay, what about the last row of A? Okay, the last row of A is non-zero because I call a row as the row of 0 if all elements are 0. So if this element is non-zero, what about the last row of A? That is non-zero. The last row of A is non-zero. But not only last row of A. Now whatever is this element, forget. Put it in don't care. Dump this element, forget. One element of the bigger row also. What is the bigger row? The row of A is to B and this is non-zero. What I am telling you, this is already non-zero. And if this is non-zero, I will say that the A is to B also has the third row non-zero. First non-zero, second non-zero, third non-zero. So rank is 3. Rank of A is to B. Both are equal and equal to 3. Both are equal and equal to 3. Correct? Both are equal and equal to 3. So what is my condition? This leads to a conclusion that if lambda not equal to 6, that means lambda minus 6 not equal to 0, the condition I just told you is rank of A equal to rank of A is to B and both of them are equal to 3. Hope this is clear. Both are equal and equal to 3. Both are equal and equal to 3 and this is what is the condition of, dear, this is what is known as the condition of unique. This is what we call it as the condition of the unique solution, right? This is what we call it as the condition of unique solution. For unique solution, that means mu is not coming into the picture. Mu is not coming into the picture. Okay. So now I want to summarize a simple story here. Okay. The story is, okay, very, very important. I want to simply summarize a story here. Okay. See what has happened. Okay. What has happened. Okay. Just, yeah, let's take another slide here. Just a second. Let me just add up a blank page here. Just a second. Yeah. Okay, yeah. Now have a look into it. Okay, what is the first condition we discussed with the system of equation? Okay, the first we took that if lambda equal to 6 but mu not equal to 20. Okay, what happened? We understood with the equation also. What happened with respect to equation? Okay, we got contradiction. This is already explained. I will not repeat this point. Some issue with the system, I think. This gives me contradiction and hence we have no solution. What we have is no solution. Confirm, na? Okay, but next condition we got is lambda equal to 6, mu equal to 20. What is the answer we got? We got the answer just now as infinite solution. We got the answer just now as infinite solution. But dear, if lambda equal to 6 and mu equal to 20, let's go back and see what happens to the actual equation. Dear, if lambda equal to 6, see here, if you place lambda 6, if you place mu 20, what is happening? If you place lambda equal to 6, mu equal to 20, what is happening? Equation number 2 and 3 match. Equation number 2 and 3 exactly match. That means equation third and second are replicating the information. Okay. So what you need to solve for 3 variables, you need 3 independent information. If there is a dependency in the equation, if some equations are related or dependent to each other, they are not giving any additional information. And hence in such a case, you get infinite solution. Okay. So that is what has happened. Okay. So if I again go back there, see what we have done here. Okay. In this condition, what is happening is, equation number 3 is exactly equal to equation number 2. This is exactly equation to equal to equation number 2, and this leads what? This leads to what? This leads to dependent equations. And whenever there is a dependency, in the equation, I will make you solve very simply some 2 mark question very simply by this knowledge. Okay, you have dependent equations, and what happens in the case of dependent equations? Okay, the system will always have infinite solution. Okay, then the third, okay, leave apart this one, the third condition, lambda not equal to 6. You know what is going to happen with lambda not equal to 6? Please see what is going to happen with lambda not equal to 6. Okay, what is going to happen with lambda not equal to 6? Now, if you see this structure, okay, if lambda not equal to 6, look into the A matrix. A is now a upper triangular matrix. Only look into the A part, and A is a upper triangular matrix. What is the determinant of A? You can solve normally also, but especially if you have an upper or lower triangular matrix, what is the determinant of any matrix? Determinant is simply product of diagonal numbers. Okay, so if I say lambda equal to 6, determinant of A will become 0. Okay, if this is 0, determinant of A also will be 0. But if I say lambda minus 6 not equal to 0, the determinant of A also will be not equal to 0, correct? The determinant of A also will be not equal to 0. So lambda not equal to 6 will tell you that determinant of A not equal to 0. And what we got for lambda not equal to 6? What we got? Unique solution. What we got? We have got unique solution for lambda not equal to 6. If the question is only and only on unique solution, dear, if the question is only and only on unique solution, what you can do? If the question is only and only on unique solution, what you can do? See, what can be done? Understand here. Okay, so yeah, this already we understood. Okay, this flowchart was discussed. For unique solution, okay, if I take out this condition separately, what is the condition for unique solution? Rank of A equal to rank of A is to be equal to what? Equal to n. N is the number of variable. N is what? The number of variable. Okay, so if I just repeat this condition separately, okay, what I have just told you for unique solution, rank of A equal to what? Rank of A is to be equal to n. Now suppose A is a n cross n matrix. Okay, let's say that A is a n cross n square matrix. Okay, let's say A is a n cross n square matrix. Okay, if it is a square matrix, basis of the last class, can you tell me, okay, can you tell me rank of A equal to rank of A is to be equal to n. So what is eventually the rank of A? What is eventually the rank of A? What is eventually the rank of A? That is also n. Okay, that is also n. We can compare and say that rank of A is also equal to n. For a square matrix n cross n to have rank n, which is known as full rank, because for n cross n, what is the maximum rank? What is the maximum rank is n. So for a matrix, for a square matrix to have the maximum possible rank, we also call it as full rank. For a square matrix to have full rank, what is the condition? We discussed very important condition in the last class. Okay, for this to happen, the determinant of A must be non-zero. That means, dear, if the question is only on unique solution, if the question is only and only on unique solution, what you can do? You can just check the determinant of A. If it is non-zero, then the system will have 100% unique solution. But if the determinant is 0, then it may have infinite solution or no solution. That we have to figure out. Okay, what is the official way to figure out? The rank. Okay, but what is the unofficial way? Okay, there are 3 questions. For unique solution, only determinant is the method. Determinant A not equal to 0, unique solution. Okay, then if it is unofficial or logical method, for infinite solution or no solution. Okay, for no solution, contradiction is the logic, and for infinite solution, dependent equation is the logic. Okay, for infinite solution, dependent equation is the logic. Okay, so this actually plays an important part. Okay, if you are able to get hold of this. Okay, this actually, okay, for no solution, what is important is contradiction, correct? Right, and for infinite solution, what is important? For infinite solution, what is important? Dependent equation. If you understand this, many of life will become easy. Many of the questions will be easily solvable. Many of the questions will be easily solvable. Okay, so let's go to a particular question here. Yeah, have a look into this question. GATE 2008 CSE 1 mark question. GATE 2008 CSE, only 1 mark question. Tell the answer for this. Very, very simple question. Come on, place the answer for this. Okay, let's check out. The system of equation has unique solution. The question is only on unique solution. The what should be the approach? The question is on only on unique solution. So the approach will be only one simple approach. Determinant A not equal to 0. Correct? Only use the approach determinant of A not equal to 0. Okay, so determinant of A, what are the numbers in A? Okay, the coefficients of x, y, z. Here it is x1, x2, x3. Name of variable could be anything again. Okay, so x1 plus x2 plus 2, x3. The numbers, the coefficients only you have to pick up 1, 1, 2. Second, 1, 2, 3. And third row, 1, 4, A. Okay, everybody can calculate the simple determinant. Okay, this you have to check and put it equal to, put it not equal to 0. That's it. Put it not equal to 0. So if I try to solve this determinant, what is there in this? Okay, if I try to solve this determinant, okay, around the first row, if I expand 1 into 2a minus 12, okay, minus of 1, then its minor is a minus 3, and plus of 2, this is a, okay, and plus of 2, 4 minus 2. 4 minus 2. Okay, this should be not equal to 0. So solving it, 2a minus a, what will be left? A. 2a minus a. Then minus 12 plus 3 minus 9, and this is plus 4. So minus 5. Minus 5 is coming now, right? Okay, 2 to 4. Okay, plus 7. Yeah, correct. A minus 5. And what you should do? Not equal to 0. Right? Not equal to 0. What is the answer here? Simple question. If a minus 5 not equal to 0, okay, the only possible condition required for unique solution is a not equal to 5. Okay, that means A can take, option number D, A can take any real number, but what? Except 5. A can take any real number, but except 5. A can take any real value except 5. Any doubts, please let me know. If you have any doubts, you can clearly let me know. Any real number except 5. Okay, any real number except 5. Okay. Unique solution means only determinant. No need to go to rank or any Rouche's theorem. Direct. Out of the Rouche's theorem only we have deduced this condition actually. Here it is. The next question. Okay, GATE EC 2 marks 2014 question. The linear system of equation has what? The linear system of equation has what? Come on, answer this question now. The system of linear equation has unique solution, infinite solution, no solution, exactly two solution. You all know that official method will take you towards the rank, but can we save time? Okay, by a logical approach. By a logical approach. Okay, look into the number, observe the numbers. Observe the numbers. See, the observation can be if you multiply 5 by 2, you get 10. And when you subtract 14, you will get 10 minus 14 minus 5. Okay, this number will come. But this has to satisfy throughout the left hand side also. Okay, so what is that I told you? I multiply, okay, twice the equation number 1, and then I am going to subtract 3. Okay, let us see what is the result. Let us see what is the result. Okay, so now see. Okay, see this. Okay, twice of 2 minus 1, 3. Twice of 1 minus 2, correct, 0. Twice of 3, 6 minus 5, 1. Left hand side also matches. Dear, left hand side is also exactly matching. So when I do this operation, okay, what I am getting? Twice of equation 1 minus equation number 3, what I have just got? I have got equation number 2 as it is. What does this mean and what is the answer then? Okay, what does this mean and what is the answer? No shadow. For any type of question, please remember, if the system has more than one solution, it will always be infinite solution. It will not have 2 solution or 10 solution or nothing. If it has more than one, it will always have infinite solution. Okay, that is for sure. That is for sure. Okay, so equation number 2 is twice equation number 1 minus 3, and there is a condition in which you have dependent equations, right? There is a condition in which you have dependent equations, and in case of dependent equations, you get how many solution? Infinite solution. Now, I give to you as an option. You want to try by the rank method, Rouche's method. Okay, rank of A equal to rank of A is to B. If you want to try, you will still get the infinite solution. Again, you will get rank of A equal to rank of A is to B. Both of the ranks will be equal but less than 3. Both will be equal but less than 3. The rank of both of them will be 2 actually. But why? Okay, you are able to save time. Why? Not required. Not required. Okay. Not required. Okay. Directly we are able to solve the questions. Okay. Next. Okay. The set of equations x plus y plus z equal to 1, ax minus ay plus 3z equal to 5, 5x minus 3y plus az equal to 6 has infinite solution if what? This will have infinite solution if what will happen? Now see, directly the question, GATE 2019 mechanical 2 mark question, directly they are telling infinite solution, and infinite solution is related to, like I told you, no solution means contradictory equation, infinite solution means dependent equations. Okay, so if I try by that logic, all my rank calculation, all my elementary row operation, row echelon form, all of the time will be saved here. All of the time will be saved here. So you try to see the efficiency of the method now. Okay, so now dependent equation. Now what is dependency here? See, 1 plus 5 is 6. I will try. What is the hint to start? If you see the right hand side, if you just see the right side, they are exactly matching just by addition. 1 plus 5 is 6. 1 plus 5 is 6. Right side has matched. Okay, so what is that I will try? If right side is matching, I will just try equation number 1 plus equation number 2. Okay, equal to what? Equal to equation number 3. Because right side is matching, that gives me a motivation that left side could also match. Okay, so if this is correct, it should be correct on all the coefficients of x, y, z. Okay, so what does it mean? 1 plus 2 equal to 3. I am trying out. Okay, so see here, 1 plus a, coefficient of x, 1 plus a should be 5. Okay, 1 plus a should be 5. This tells you how much is a. This tells you a equal to 4. Okay, but if a equal to 4 is the answer, it should not only match only x coefficient, it should match entire left hand side. Entire left hand side 1 plus 2 should be equal to 3. Okay, so now with the coefficient of y, this was with respect to x, I will mark also. Okay, with respect to y coefficient, okay, 1 minus a is equal to minus 3. If a is 4, correct? If a is 4, 1 minus a, 1 minus 4 will be minus 3, correct? It should also satisfy the z story. What is there in the z story? 1 plus 3 should be equal to a, right? 1 plus 3 should be a, correct? A is 4, the 1 plus 3 is 4, correct? So a equal to 4, I can say that with a equal to 4, equation number 1 plus equation number 2 will be equal to equation number 3. Okay, so yes, this can be true. Okay. Yes, this is true if a equal to 4. This is true if a equal to 4. So what is the answer to the question? A equal to 4. Option number A. What is the answer to the question? Option number A equal to 4. The answer is simply a equal to 4. Simple enough. Simple enough to come to the conclusion, right? Any doubt, let me know. Any doubt. Without applying rank, without applying any elementary operation, we are able to solve and get to the correct answer. We are able to solve and get to the correct answer. Okay. Anyways, next question. Okay. The following linear system of equation is consistent. Okay. GATE 16 civil 2 mark question. They are only talking about whether the system is consistent. If A, B, C satisfy what? Okay. If A, B and C satisfied what? The system is consistent if only what condition required? Okay. The rank of A equal to rank of A is to B. That is the only condition required. rank of A equal to rank of A is to B. That's it. That is what is the only condition required. Rank of A equal to rank of A is to B. Okay. Right. So if ABC satisfies what condition? Okay. ABC satisfies what condition? Consistent means unique solution or infinite solution, any of them. Any of them. Okay. Okay. Rank of A equal to rank of A is to B. Okay. What is that can be thought about? Think about this. Think about this and get the answer. Okay. Again, by a shortcut, you can say the answer. Again, by a shortcut, you can say the answer. How by the shortcut you can say the answer? Okay. How by the shortcut you can say the answer? Okay. See, can you just play with the numbers again rather than going for the rank? Can you just again play with the numbers? Okay. What is there in the numbers? Okay. So see here. Okay. My method number 1, and then I'll tell you, if you're not able to understand numbers, I'll again tell you the official method also. No problem there. Okay. Now see here. Okay, you multiply the first equation by 3 and then add with the 2. So 3x plus 2x, 5x. 3 to 6, 6 plus 3, 9. 3 into minus 3, minus 9 plus 3, minus 6. Left hand side will match. Left hand side will match. Okay, so what I am trying, okay, I am giving this as a try. It's a play of numbers that makes the life easy. Okay, otherwise you'll have to go to some calculations. That also, okay, I'll show you once again. Okay, so what is there? I have just tried 3 times equation number 1. Plus equation number 2, I get equation number 3. Okay, left side is at least matching. Left side is at least matching. Okay, so with this, left hand side is automatically matched because left side all numbers are given. Right side some ABCs are given. Okay, so what I am able to say that left side to at least matching here, correct? Left side is at least matching. Okay, so right side should also match. If right side will match, what will happen? If right side will match, what will happen? Okay, so 3 times equation number 1, that is 3a, right side, that is 3a, plus equation number 2, that is plus b, should be equal to c. Okay, that means 3a plus b minus c equal to 0, equal to 0. Okay, gives you what? Okay, gives you dependency, because if this is correct, then equation number 3 is twice, equation number 3 is equation number 2 plus thrice equation number 1. That means you get dependent equation. Okay, so under this condition, I am able to say that you have got dependent equations. You have got what? You have got dependent equations, and dependent equations means infinite solutions, and system is solvable, it is consistent. Okay, infinite solution, so 3a plus b minus c. Okay, consistent means either unique or infinite solution, any of them. Okay, okay, rank of A should be equal to rank of A is to B. Infinite solution also ranks are equal, ranks are equal but less than n. Only when ranks are not equal, then the system is inconsistent. Okay, so correct answer here is option number B. 3a plus b minus c is equal to the 0. 3a plus b minus c equal to the 0. Correct? Right. 3a plus b minus c equal to 0. Because if you don't do it, okay, so then what you can do? Okay. Okay, if I show you then if you want the conventional method, okay, let's again repeat the conventional method. Okay, so that you understand and settle that method also in the brain. Okay, that also is okay. X plus 2y minus 3z is 0. But rather than this, I will directly write down the entries in the form of matrix. What matrix I'm looking for? A is to B. What matrix I'm looking for? I will be looking for the matrix A is to B. So what is that A is to B? First row, 1, 2, minus 3 and A. Okay, first row, 1, 2, minus 3. 1, 2, minus 3 is to A. Okay, what is there? Second row, 2, 3, 3b. Okay, this is 2, this is 3, this is 2, this is 3, this is 3, and this is b. The next is 5, 9, minus 6 and c. Okay, this is 5, 9, minus 6 and c. This is again for the understanding of the Rouche's method, the rank method. Okay, otherwise we have solved the question. Okay, any doubt in that previous method, the dependency method, you can let me know. Okay, that is, see, I am focusing more there because that is what I want you to adapt so that you are quick in the exam hall also. Okay, but now what is there? If you want to, go for rank, row echelon form will be required. Okay, first I need to make this as 0, this is 2. So what is the first operation I will start? 2 minus 2. Okay, 2 minus 2 means R2 will be replaced as R2 minus twice of R1. R2 will be replaced as R2 minus twice of R1. Okay, R2 minus twice of R1. So if I do this now, see, and also one more, not only this, 5 also has to be made 0. The 5 minus 5 into 1. Okay, 5 minus 5 into 1. So what will I do for R3? R3 I am going to make it as R3 minus 5 R1. Okay. So on doing this much, what is going to be the A is to B matrix? Keep looking with me. On doing this much, what I am going to get? Okay, this is 1, this is 2, this is minus 3, this is A. Okay, then R2 minus 2 into 1, 0. Okay, then 3 minus 2 into 2, that is minus 1. Okay, 3 minus 2 into minus 3, that becomes 9. Okay, and then this is B minus 2A. Okay, then last 5 minus 5, R3 minus 5 R1. 9 minus 2 into 5, minus 1 again. Minus 6 minus 5 into minus 3. So 15 minus 6, this is 9. Okay, this is 9. And then last is C minus 5A. Okay, one more operation will be required here. And what is that one more operation? Now add R3 and R1. So that here also you will automatically get 0. Not add, sorry, subtract, because both are equal, na? Subtract. Okay, so next what I am doing is, okay, I am just going to subtract here. Okay, what is that I am going to subtract? Now R3 will be written as R3 minus of R2. R3 will be written as R3 minus R2. Okay, so when I do this, now see the net effect, what is going to happen? What is the net effect going to happen? Okay, I'll do it here only, just a second. Yeah. Okay, so R3 minus R2, let's do it. So when I do this, what is going to happen? See here, what is finally going to be the A is to B, that is, then subtract R3 minus R2, 0. Then this is also same 0, 9 minus 9 also 0. B minus 5A minus C minus 5A minus B minus 2A. Okay, so C minus B and minus 3A, correct na? Minus 3 minus 5A plus 2A it will become. Okay, so that is minus 3A. Okay, so now dear, this is confirmed that because the last row of A is 0, the rank of A will be only 2, because in the row echelon form, okay, rank of A is number of non-zero row. We have the row echelon form now. Why it is in the row echelon form? Okay, number of zeros, beginning nothing, then 1 0 and then 3 zeros. Okay, number of zeros are in the increasing form. Okay, number of starting zeros are in the increasing order. Rank of A equal to 2, and then next, you want the rank of A equal to rank of A is to B. Consistency means what? Rank of A should be equal to rank of A is to B, and that both of them should be equal to 2. That means the rank of A is to be also 2. That means the third row of A is to B should also be 0. Third row should be 0. That means this particular element should be 0. Okay, that means C minus B minus 3A is 0. So what is the value of, okay, just reversing the sign, 3A, okay, plus B minus C equal to 0. Say, same thing we have written or not? Same thing we have already written or not? If you see the answer, 3A plus B minus C, the same thing we have written here. 3A plus B minus C. Answer was option number B, automatically deduced. Okay, by our numbers logic. How we have reduced earlier? By our number logic, and even by the calculation we are able to say that. Even by the calculation we have been able to say that, correct? Even by the calculation we have been able to say that. Okay. All right. 2025 EE 1 mark question. Current year 2025. Simple question. Very simple question. So if you have understood these techniques, even this 1 mark question, it does not deserve any calculation. You can just look into the numbers and answer to me. What is there in this question? Okay, let A be the matrix given to you and B is given to you. The system of equation AX equal to B. Very clearly the second row, Okay, the second row, okay, here when you write A is to B also, it's completely going to match. Even if you write down in the equation format, what you are going to feel? You are going to feel that when you convert this to the equation also, equation number 2 is exactly equal to equation number 1. Equation number 2 is exactly equal to the equation number 1. And that means dependent equations. And what happens in case of dependency? What happens in case of dependency? The system of equation will have infinitely many solutions. Finished. The system of equations will have infinitely many solutions. Option number A. Okay, you try by rank and any other thing, you are still going to get the very same answer. You are still going to get the very same answer. Okay. So that's what, even here you don't have to observe the numbers. In some of the questions, it is what to add, what to multiply so as to get the dependency equation. This is direct equal. Okay, equal is also a dependency only, na, at the end. Okay, this one is direct equal. Okay, so very simply you are able to get hold of your answer, correct? Very, very simply. Just a second. Yes. So guys, crucial updates and information for all of you, that if you are willing to join for the offline regular batch, okay, to be the competitive atmosphere among hundreds of students and directly, face to face in front of the India's best known faculty team for ECEE, that is with the OM Institute. So you can enroll for our offline batches at the Hyderabad Center. Okay, the offline regular batch for EE. Okay, just started 31st July. We'll very soon give you the updates of the new batch also, because this is also recently started. You can join to it. And for EC, the next batch starts on 10th of August. Okay, for electronics and communication. The fee 65,999 is currently priced at 54,999. And along with that, there are some special discounts which is mentioned along the side. For any details about the timings, pricing, fee, faculty, you can contact 951569403, or you can visit our website www.ominstitute.com. Right. In case you can't travel to Hyderabad for any reason, maybe you're college going student or etc., and you can't attend the offline classes, you still want the same content by the same best ECEE faculty team, you can enroll to the OM online live course. Yes, the OM Institute online live course, okay, which is available for Gate 26 and Gate 27 both. For Gate 26 with 1 year validity, the fee is 19,999 currently, and for 2 year validity, that is for Gate 27 course, it is 28,999. Okay. Also guys, the batches for AE examinations, okay, that is the Transco or Discoms for AP as well as Telangana. So if you're looking for offline batch for AE, okay, because again, a good huge number of vacancies are expected this year, okay, for the AE. So the new batch for AE offline starts August 4th. Okay. Yeah. So that's it for this video from my side. Okay. Thank you. Stay connected and all the very, very best. We'll bring you another video on linear system of equation only, where we'll talk about homogeneous system of equation. This was non-homogeneous system of equation. Next, we are going to talk about the homogeneous system of equation. Okay, dear. Bye-bye. Thank you. Stay safe and take care of yourself.